In this session, we discuss about the two-dimensional array, three-dimensional array with example programming. Two-dimensional array, the syntax of two-dimensional array is data types, variable name. So after the variable name, the pair of bracket, two pair of bracket is there. The first pair of bracket refer the row, the second pair of bracket refer column. The example for the above syntax, integer, this is the data type. We can put float, double, so any data types, whatever we need, we give the data type integer. Then array name A, this is a row, this one is a column. This is array declaration. First we declare the array, but the declaration at the time of compilation, so based on the declaration statement, the compiler is allocate 6 integer locations, continuously 6 integer locations. So at the time of accessing, we access like this, that is a row, 0th row, 0th column. We assign value to 0th row, 0th column. Then we assign value 3 to 0th row, first column. 0th row, second column is 5. So this is called array initialization. This is a declaration. So compiler will declare the memory location. This is initialization. It's initialize the value to that memory. For our learning purpose, this is a memory mapping. But in computer, the memory are continuously allocated. So totally for 2 by 3 mean 6 locations. Each location has 2 bytes because it is integer type. So 6 into 2, 12 bytes. So it's continually allocated 12 bytes. But for our easy understanding, so this is this diagram for memory mapping for 2 rows, 3 columns. That is the row 1. That is 0th row, first row. Totally 2 rows. 0th column, first column, second column. Totally 3 columns. So rows and columns are start with 0. If it is a 2 rows, 3 column, but start with 0, so it's end with 1. Because it start with 0, it's end with 1. Because it is a 2 row. For 3 column, it start with 0, end with 2. 3 columns. So this is a 0th row. A matrix 0th row, 0th column. This location is 0th row, 0th column. Say 0th row, first column. 0th row, second column. Then first row, 0th column. First row, first column. First row, second column. So this location name is A of 0, 0. Because 0th row, 0th column. The location value is 2. The location address is 700. We already discussed about the address in a one-dimensional array. So all addresses are continuously allocated. If ordinary variable, it discontinuous memory allocation. So it is continuously allocated. So the 0th row, 0th column address is 700. The next location is 0th row, first column, 702, 704, 706, 708. So it's a typing error. Only 2 bytes for integer. So 706, 708, 710. The last address is 710. So the address will continue row wise. Then come to the beginning of next row, it continue again. It not continue column wise, that is 700, 702. It is wrong. So it's continue row wise. It comes to the next row. Then it's continue the address. That is 700, 702, 704, 706, 708, 710. This is the address. So we are also write the statement the above, that is declaration, is a separate statement. The initialization are done separately. So in this statement we are done in a single statement, that is declaration, and the both are in single statement, declaration and initialization in single statement. So integer a of 2 3 equal to 2 3 5 4 7 6. This is also initialize appropriate locations, that is 2 is assigned to 0 0 location, 0 1 0 2, then first row 0th column 1 1 1 2. So this is also equal. We also write like this. This is also declaration initialization, but it has some readability. We can easily understand which one is a row, which one is column. So how many columns, how many rows, we can easily understand that. But both are equal. This is also understood by compiler, this is also understood by computer. That is readability. The readability is high compared than this. We are also write like this, that is here no column, no row value is not available. Row value is not available. Here row value is not mentioned. Only column value mentioned. So this is also valid one, because the column value is 3. So it's divided by 3. First take 3 values, then next take 3 values. Totally 2 rows. You can easily find out 2 rows. But these are all invalid. If we put row only, no row, column. Only we mention row, but no mentioned column. So this is invalid because it cannot able to find the how many values in column. So the 2 row column both are missing here. This is also invalid one. Now we apply the above 2-dimensional array for matrix multiplication. The matrix multiplication is a good example to understand the 2-dimensional array. So the what is this is a matrix. A matrix has 2 rows 3 columns. A matrix is 2 rows 3 columns. B matrix is 3 rows 3 columns. So some mathematical rule is there for matrix multiplication. So matrix multiplication has some mathematical rule. One is that is A matrix column should be equal to B matrix row. A matrix column should be equal to B matrix row. If it is not equal, that matrix cannot able to make multiplication. So this is the rule. So A matrix column and B matrix row are equal. Then the C matrix result values are stored in C matrix. After the multiplication, the result will stored into C matrix. This is 2 row 3 column. B matrix 3 row 3 column. How it is what will be the C matrix row and column? That is, you get A matrix row is a C matrix row. A matrix row is a C matrix row. Then B matrix column is a C matrix column. Here just we that row, A matrix row represented by I, B matrix column should be equal to B matrix row. So we represent by J, this letter J. So this is also J. It should be equal to that, so J. Then in this one is a K. It may be vary, but it should be equal. That is A matrix column and B matrix row should be equal. So then we get the result A matrix row and B matrix column. So what is the letter for A matrix? I. The row, A matrix row denoted by I. So I. Then B matrix column denoted by K, Ik. C is Ik. What is the value I? 2. What is the value of K? 3. So 2 rows 3 column. The result will be 2 rows 3 column. Okay. How can we multiply that value? So this is the multiplication process. First take 0th row of A matrix. It has 3 values. Then we take 0th column of B matrix. It also has 3 values. Then we multiply appropriate values, that is we take A matrix 0 0 multiply with B matrix 0 0. Then we take A matrix 0 1 3 multiply with B matrix first row 0th column. Then we take 0th row second column, 0th row second column value 5 is multiplied with second row 0th column. So after the multiply we add, first we multiply 2 into 2 plus 3 into 6 plus 5 into 2. So it will give one value. So that value is C matrix 0th row 0th column value. This is equations for that. This is a processing formula. If we want to find the C matrix 0th row 0th column value equal to A matrix 0th row 0th column into B matrix 0th row 0th column plus A matrix 0th row first column into B matrix first row 0th column plus A matrix 0th row second column into B matrix second row 0th column. Then we find the value of C matrix value of C of 0 1, 0th row first column equal to, first we take this value into these three values, that is first column of B matrix. So 2 into 3, that is A of 0 0 is B of 0 1 plus A of 0 1 into B of 1 1. Then A of 0 2 into B of 2 1. Then we want to find the value of C of 0 row first column equal to, then we take again three values, that three values are multiplied with the second row of B matrix, that is 2 into 4 plus 3 into 8 plus 5 into 5. This is the equation for that. Then we want to find the value of C of first row 0th column equal to, we get first row, this first row with first column, it will give one value. Then A matrix first row with second column, it will give one value. Then A matrix first row with B matrix second column, it will give one value. So this is a formula for that. Now we find, now we want to find the logic for the matrix multiplication. So then only we can write the program for that. So that is 0 0 equal to A of 0 0. Okay. So this already we denote that is A matrix row is I, column is J, B matrix row is J, column is K. So there is I, J, J, K. This one. This is I, K. I value, so up to 3 equations is 0. After that it will change to 1. This is also 1. This is also 1. So first after the 3 equation it changed to 1. I, J, this is 0, but it changed 1. Then it changed 2. So it changed 3 times per equation. It changed 3 times. Then it start again 0. It changed 1, 2. It changed 3 times. So then again it changed 3 times. If I change 1 time, within that 1 time, J change 9 times, because for equation 3 times. So J rotate 9 times if I rotate 1 time. Then now we see K, value of K. K is 0. Here 0. Here also 0. Here also 0. But one equation it is 0. Then next equation it change. Then next equation it change. So it's change 3 times only. So I change 1 time, J change, K. K change 3 times. I change 1 time, K change 3 times, J is changed 9 times. So the rotation Based on that we write the loop, nested loop for that, because it required 3 for loop. Which one is the first loop, which one is inner loop, which one is innermost loop? Totally 3 loop is required to process the matrix multiplication. So we find the outermost loop. So I is the outermost loop because the rotation is less, that is one time, and next change, it changed 2 times only for entire processing. So the rotation of I is only 2. The rotation of k is change 6 times. I 2 times, k 6 times, but j 9 times, 18 times. Per equation it is 3. So totally 18 times. J changed into 19 times, k changed 6 times, k changed 6 times, j changed 18 times, I changed 2 times. So first, what is the outermost loop? Which one is the less value? This is the outermost. Which one is the higher than that? This is the inner. Which one is higher than all? This is the innermost. So as per our processing formula, the outermost loop is I, inner loop is k, innermost loop is j, I, k, j. This is the program for the above example, above logic, the matrix multiplication. This is a program for matrix multiplication. First we declare, that is integer a of 2, 3. It's allocate 6 locations and b 3 by 3. The result will be 2 by 3. So we declare all variables I, j, k. Sum equal to 0. So printf enter first matrix. So 0, start with 0, end with 2, less than 2, 0, 1, because it is a row of A matrix. Then 3, this is the column of, so we get the value. First we A of 0, 0, then j rotate, A 0, 1, A 0, 2, it comes out inner loop and continue the outer loop. Now I value is 1, then 1, 0, 1, 1, 1, 2. Then it come to the out of the loop, come out the inner loop. So the value is 2, it comes up. Though after getting 6 values, it will come out the loop. Then it display enter second matrix. So it also, because B matrix 3 rows 3 columns. So here the last value is 3, 3, 0, 1, 2, 0, 1, 2. So I value is 0, rotate 3 times, j 0, 1, 2. So 0, 0, 0, 0, 1, 0, 2. Then it come out the inner loop, then continue the outer loop. The value is I value is 1, 1, 0, 1, 1, 1, 2. It comes out the inner loop. 2, value of I is 2, 2, 0, 2, 1, 2, 2. So after getting 6 values, it come out the outer loop. So now 6 that is totally 6 values are stored. First 6 values stored in A array, and then in B locations it has 6 values. So then we start the processing. First outer loop, already we find the outer loop. Which one is the outer loop? I is a first loop. So I last location is 2, the row is 2. That is we denoted already on letter, I is 2. So less than 2. The next one is k, because this is a less rotation. This is higher than I, j is higher than k. So this is outer loop. I equal to 0, I less than 2, k equal to 0. What is the k value? 3. K less than 3, k plus plus. C of ij, because initially all locations has garbage value and default it is a automatic storage class specifier. So the default value of each location is unpredictable value and also called as garbage value. So we initialize 0. So 0 is assigned to C of 0, 0. This one is k, C of ik 0, 0. Then j equal to 0, j less than 3, j plus plus. C of ik equal to C of ik plus already 0. The initial value of C of 0, 0 is, then at A of 0, 0 into B of 0, 0. and continue the inner loop. Now j is 1. A of 0 1 into b of 0 1. A of 0 2. A of 0 2 into b of 2 0. So as per the previous equation, if it will come out the innermost loop, that is j loop, it calculate this one. If next come out the k loop, it calculate. So add with the already some value is there, so we add with this value. So then so 3 times j executed, so 3 values are calculated and assigned to c of 0 0. If come out the j loop, the first time it get completed, come out the j loop, it continue the k loop, then it is increased, then rotate j 3 times, so it calculate another value. It's come out the j. Now value of k, it's come out the j, the value of k is 2, so it executed. Then it after comes out, the k loop is also 3 less than 3, condition false, it's come out the inner loop, it continue the I loop. So now value of I is 1, then again to the same, that is 1, k is 0, j rotate 3 times, k is 1, j rotate 3 times, k is 2, j rotate 3 times. So after come out the k loop, then it's come out the I loop, k loop, and now the new value of I is 2 less than 2, condition false, it's come out the entire loop. Then it just display the value, the result is, so it's rotate 2 rows 3 columns, it is the result. So 2 rows 3 column, print of 0 0 0 1 0 2, because this is a for loop. Immediate statement is a for loop statement. If we not give opening brace closing brace, the immediate statement accept as in the for loop statement. So it execute 3 times 0 0 0 1 0 2. So then it come out the j loop. So just print backslash and it come to the new line. Then it continue the outer loop. It's again rotate 3 times, print 3 value. It's come out the loop out. So the result will be a row by column. Otherwise, if we not put print slash n, it continuously 6 values printed. For our readability, we can display row by row. So this is the output for the above matrix multiplication program. Now we discuss about the 3-dimensional array. 3-dimensional array is syntax is similar to the 2-dimensional, 3-dimensional. The first we put data type, then we give the variable name. After the variable name, we give 3 pair of brackets. This is a 1 pair, second, third. 3 pair of bracket is there. So first one is M R C. So this is the total number of matrix. For easy understanding, so M represent the matrix, R is a row, column. For example, integer A 2 3 3. So 3 by 3, 3 rows 3 column, total number of matrix is 2. So what is the total locations? 2 into 3 into 3, 18 locations is required. If it is because integer, so 18 into 2, 36 bytes is required. Here we put 0 0 0. This is a declaration. Here we initialize it. 0th matrix, 0th row, 0th column. Just by using this diagram, we easily understand that. This diagram for this declaration, that is 3 rows, 3 columns, 3 rows, 3 columns. This is a 0th matrix. Totally 2 matrices is required. 2 matrix is represented here. So 3 by 3. This is a 3 by 3 matrix. This one is a 3 by 3 matrix. The matrix number is 0. This matrix number is 1. What is the value? 0th matrix, 0th row, 0th column. This is the value. What is the location name? A of 0th matrix, 0th row, 0th column. This is the address. There is 700, 702, it's like a 2 dimension, right? First continue row by row, first continue row, then next row, it's continue. Then it is also 716, 718, 720. It is also continuous memory. We can also declare both are in a single statement, that is declaration and initialization. That is integer a of 2, 3, 3 equal to, here we initialize it. This is a zeroth matrix. This is one of the matrix 3 by 3. This is another matrix, totally 2 matrix, 3 rows, 3 columns. So totally 2 matrix. So this is a memory mapping for that example. If we want to access the value, this is a location. What is the location of this? A of the variable name is A, matrix number is 0, A of 0, A of 0, first row, first column, A of 0, 1. What is the location of this? Matrix name is A, matrix number is, that is variable name is A, matrix number is 1, row is 1, column is 2, A of 1, 1, 2. This is the location. We also declare 4-dimensional array. So when which places are applicable? The what is the application of 3-dimensional array? I will explain one scenario. If we want to store 2 batch students marks, each batch has 20 students. Each student has 3 subject marks and with roll number. So each student require 4 variables, totally 2 batch. So per student 4 variables to store 3 subject mark with roll number, 4 variable. So first batch 8 locations is required, then second batch 8 locations is required. So in this situation we can easily declare 3-dimensional array. First, number of batch, in our case it is a 2 batch. Number of student, 20 students. Number of variable for each students, 4 for 3 subject marks and 1 roll number, totally 4 subject. So 2 to 24, just we declare 224. So a single variable, we can easily access that value and we get the input, process and output by using the 3-dimensional. In similar way we can declare 4-dimensional, that is we put 4 pair of bracket, then we give the value and then we calculate, right? So this is the different types of dimensional and the different types of array. And there is 1-dimensional, 2-dimensional, 3-dimensional.